Hello, my name is Iris Young, and this is my bonus assignment. Okay, so this is the article that I chose to use, and it's how fluid type influences acute hydration and muscle performance recovery in human subjects. Okay, and let's get to the presentation. Okay, and to begin with, this is the introduction. So the study I chose, like I said, is how fluid type influences acute hydration and muscle performance recovery in human subjects. So exercise and heat exposure can induce a lot of dehydration and an elevation in extracellular fluid osmolality, which can lead to impairments in both exercise performance and thermoregulation. Previous research has suggested that deep ocean mineral water may have the potential to enhance post-exercise recovery of exercise performance. And this team aimed to investigate whether the acute rehydration and recovery of muscle strength would be more effective with deep ocean mineral water compared to other drinks like a sports drink or a mountain spring water following a dehydrating exercise. So the hypothesis that the team came up with was that the muscle strength would decline after dehydrating exercise, and that the subsequent recovery of muscle strength and hydration would be influenced by the type of rehydrating fluid that was used. Okay, so the methods. In a crossover study with a counterbalance design, there was 8 female and there was 9 males that participated, and they underwent a dehydrating exercise protocol in a heat-stressed environment. And after this, they would achieve a 3% loss in their overall body mass. And after this, participants were rehydrated with an equivalent volume of either a deep ocean mineral water, or a mountain spring water, or a carbohydrate-based sports drink. The relative hydration was assessed through salivary osmolality, which is abbreviated most of the time as SOSM. And muscle strength was evaluated using peak torque derived from a leg extension maneuver. So how they kind of did this was that each participant would be required to complete the dehydrating exercise protocol 3 times. And so there was 1 trial for each hydration fluid. So each participant would be doing all 3. So the deep, the spring, and the sports. And there would be a 48-hour separation period. Alright, so continuing with the methods. So this is the dehydration protocol, which if you look, you can see that it says Biodex peak torque extension, so that's going to be the baseline value. And then they also record the data, like just overall data collection, like a heart rate, body weight, and then they'll do the exercise training, which was a stationary bicycle, and it's 15-minute intervals. And then they would also collect that after that. And if you did lose 3% of your body mass, you would go right into another value, a Biodex peak torque. They would take the value, and then, but if you didn't, you would have to redo the exercise training. But if you did, once you do, the hydration protocol would be activated. So the phase 1 of the hydration protocol is the fluid. It would just be like the fluid intake, which is the half total volume loss, and then there would be saliva sample, and then there would be phase 2, and then at the end there would be the Biodex peak torque extension, so just recording the overall results at the end. Okay, and then the results. So the SOSM, the osmolality, significantly increased with the loss of body mass during the dehydrating exercise protocol. And then the males took less time to reach the 3% body mass loss when compared to females. So according to figure 3, so if you look at the diagram, so if you see on the side vertically, it says time to 3% body mass loss. So if you look comparing like the sexes, females are higher, so it took them longer than males for each 3 of the waters. And then this is another diagram as well. And then the team used a mono-exponential model to fit the return of the osmolality, the SOSM, to baseline values during the rehydrating phase. Whether fitting stimulated or unstimulated SOSM or osmolality, the male and female participants receiving the DEEP as the hydrating fluid exhibited the most rapid return to baseline osmolality regardless of the fit parameters. So according to figure 2, so if you take a look at this, it's just, if you look at like the DEEP and the sports and the spring, it's just the DEEP as the hydrating fluid exhibited the most rapid return to baseline. Rather than these, because these just, they're both here quicker. And then this is just the stimulated and unstimulated saliva. Alright, and then the males compared to females generated more peak torque at baseline. And these are just some like values that were recorded showing that, and then immediately following the 3% body mass loss. And then participants experienced a loss. We also identified, or the team identified, a significant effect of rehydrating fluid and sex on post rehydration peak torque, and this is just showing like the figure 4 and table 2. Just a lot of like values. It's just showing like the baseline, like it coming to baseline after like with the stimulated and unstimulated saliva, how long it took. So there's real time here. And then if you see from B to D, the bar graph representation of the one phase decay fit parameters in females and males from the DEEP, sports, and spring groups. A repeated measures 2-way determine a significant impact on fluid rate parameters of hydration that was not impacted by sex. So that's just showing here. And then the analysis indicated a significant difference in the DEEP group compared to both the sports and spring groups. So if you see at the DEEP, there's just a significant difference, like on each graph. And then table 2 is just showing like the return of the osmolality to baseline levels during rehydration. Okay, and then the discussion was, so this study like aimed to assess dehydration parameters and performance declines resulting from the dehydration exercise, and the goal was to investigate whether the recovery of hydration and muscle performance depended on the type of fluid that was used. And they observed potential sex differences in these parameters, although the study was not explicitly designed with statistical power for such comparisons. So basically, like a big discussion was the deep ocean mineral water positively affected dehydration recovery after dehydration exercise. And it's shown here, the results. And in conclusion, our findings suggest the deep ocean mineral water had a positive impact on the recovery of hydration following dehydration exercise, and there's an indication that it might be advantageous for muscle strength recovery. However, both of these aspects, as well as the potential influence of sex, warrant further investigation and future research. And then here are some pictures. All right, thank you.